All right, good morning. I'm a little upset today. Well, first of all, there's only a couple people in class right now, so that's part of the problem, people coming into class late, or people being absent. So the exam scores were horrible. Just letting you know, I'm not giving retakes. I'm not doing anything. This is semester 2. So like I said, you should have your tech stuff under control. Those technical issues should be resolved. You should know how to study for an exam. And the thing is after you fail an exam, I mean, there's nothing I can do about it. So, yeah, the good news, I'm throwing out the lowest test grade, but you can't continue to get low test grades. So there were A's, those of you got A's, congratulations. Those of you who totally bombed this test, luckily at the end of the semester, I do throw out the lowest test grade, but you can't habitually get low test grades. It will destroy your grade. One low test grade isn't going to hurt your grade. That you continue to lag. And yeah, I'm not grading on a curve. So I'm grading to a standard. And if you don't meet that standard, if I have to fail everybody in the class, that's what I'll do. So have no doubt about that. I'm not passing you along just to give you a grade because everybody's failing. There's only like 10 or 13 students in this class now, so there's no excuse, in my opinion, for messing up. It's your responsibility to ask me questions. I'm not from the Psychic Friends Network, so when you don't ask me questions, I assume you know what's going on. So when you turn around and fail a test, nothing I can do about it. So I'm opening myself up to you. You can ask me questions, but I'm not getting retakes. I'm not doing anything like that. So need to be prepared for exams. They're 60% of your grade. All right, today I'm going to try to talk more about these rational functions. What I'm doing is I'm giving you parts so that you can graph them eventually. And so I've talked about, I'm on page 398. So take a look at page 398. The other day we looked at finding the domain. I was going to skip the arrow notation, but I'm not. I'm going to teach it today. The next thing I taught was how to find vertical asymptotes. And then we ended yesterday looking at the horizontal asymptotes, looking at conditions. And so what I want to do right now is I want to put those problems on the calculator so you can see what the graphs look like. So have your graphs, have your calculator ready. So the first problem I did with the horizontal asymptotes look like this. And when you put this on the calculator, this must be in parentheses. If you just put it in the calculator with no parentheses, this is what the calculator is going to do. And that's going to be the wrong graph. So the calculator does not have a brain. So you have to be real clear about 4x divided by that quantity. Otherwise, it's going to do that, which is wrong. So you're going to grab your calculator, and you can't just put it in the calculator part. You have to go to the equation editor, which is y equals. So when you go under y equals, you're going to put in 4x. X is next to the alpha key. So 4x divided by parenthesis 2x squared. So the square is over here on the left. It's a black key. Plus 1. And then you're going to hit graph. Now your graph should look like that. If it does not look like that, you want to go to Zoom Z Standard to get a standard viewing window. So go ahead, questions about this. Your equation editor should look like that. When you hit graph, it should look like that. Now, first of all, I was talking about flaws in the calculator. Notice that the graph doesn't have any arrows. And what you're seeing here is a horizontal asymptote. And that horizontal asymptote is y equals 0. And see how it looks like the graph's hitting it? The graph should not be hitting it. So this graph looks like this. It's going up and running along the horizontal asymptote. It's going down and coming back and running along the horizontal asymptote. Was everybody able to graph that or no? All right, nobody's saying anything, so I'm assuming you know how to do it. All right, here's the next graph. So what you can do on the calculator is if I want to turn this graph off, I just hover over the equal sign and I toggle it. So when I hit enter, I just turn the graph off. If I want to turn it on, I hit enter again and it toggles it. So I'm going to turn it off and I'm just going to enter the new graph below it. So this is going to be 4x squared divided by parenthesis 2x squared plus 1. Parenthesis. So now, because I turned off the first graph, here's the second graph. And this is what it looks like in my equation editor. So see how I have the first graph off and the second graph is turned on? And when I hit graph, that's the graph. It looks like a fountain. So this is a function, but it's not a polynomial. So what this graph is doing is it's going up along a horizontal asymptote at y equals 2. So whenever it kind of flatlines like that, there's an asymptote. All right, the final graph was h of x. And it was 4x cubed over 2x squared plus 1. So let me go back here a minute. So remember, this one was in less than m. So we said that there was a horizontal asymptote at y equals 0, which is what we're seeing. So see how the graph is running along y equals 0? And on this one, n equaled m, which meant that the horizontal asymptote was 4 over 2, which is 2. So that's why we see it running along a horizontal asymptote. On this graph, n is greater than m, because 3 is greater than 2, so there is no asymptote. And the graph looks like this. So there is no horizontal asymptote. So any questions about the conditions for the horizontal asymptote or any questions about the graphing calculator? I'm going to talk about arrow notation now. So this is what I skipped yesterday, and I decided to teach it. So I'm going to show you the definition first, and then we're going to do a bunch of examples. So it looks like this. This is just an example. So the thing you need to remember is that X goes left and right, and it is the domain. Y, which is f of X, it goes up and down, and it's the range. So this is X left or right. This is Y up or down. And this arrow means approaches. And that little negative right there means from the left.
Are these new notes, Ms. Birch?
Yep. So if this is a positive, this would be from the right. If it's a negative, you're approaching 0 from the left. So I'm going to do a bunch of examples. I'm going to draw a picture of a graph, and we're going to do a bunch of these. So in this graph, I have a vertical asymptote at x equals 3. I have a vertical asymptote at x equals -1. And my graph looks like this. Now, this is not 3 graphs. This is 1 graph. It is a rational function. Notice that there's a horizontal asymptote at 0, because whenever these flatline like that, that's a horizontal asymptote. See how it's going flat? There's a horizontal asymptote. Now, remember yesterday I said that a graph can pass a horizontal asymptote, but this graph is not going to magically go up, and neither is this one. This isn't going to magically go down. It's going to run along the asymptote, and so is that one. So I'm going to give you some problems. I'm going to give you a lot of problems, and you're just going to answer. As X approaches 3 from the left, Y is approaching what? So what you're going to do is you're going to run your finger. That's not a -3. That's approaching +3 from the left. So you're going to run your finger to 3, and you're going to look at the graph. So as you approach 3 from the left, what is Y doing? Now, you're not looking at the right side of the graph. You're looking at what's happening on the left, which is this part of the graph. So as you approach 3 from the left, what is the graph doing?
Rising.
Yes, it's rising forever. All right, let's do another one. As X approaches 3 from the right, what is the graph doing? So as you approach 3 from the right, what is the graph doing?
Falling.
It's falling, right, it's falling, which would be -infinity. Now, what we're doing right now, you guys, it's leading us into calculus, actually. It's called, you have to be able to find limits in calculus, and that's kind of where this is headed. This is just an introduction to arrow notation. All right, so let's do some more. So as x approaches -1 now from the left, what is y doing? Sorry. As you approach -1 from the left, this is -1, right? So as you approach -1 from the left, what is y doing?
Rising.
It's rising, right? As x approaches -1 from the right, what is the graph doing? So you're approaching -1 from the right, what is the graph doing?
Flatlining.
As you approach -1 from the right, if the graph is doing what?
Oh, it's falling.
It's falling. Okay, now these are a little bit more trickier. As x approaches positive infinity, what is the graph doing? So what it's asking is, as you're approaching infinity forever, what is the graph doing? As you approach infinity, what is the graph doing? Is it going up forever, or is it approaching the asymptote?
It's approaching the asymptote.
And what is the asymptote?
0.
0, right? It's approaching 0. Let's do another one. As x approaches -infinity, what is y doing? So as you go to -infinity, what's the graph doing?
Approaching the asymptote.
Yep, it's approaching the asymptote, which is 0. Okay, so now what we're going to do, anybody want to ask me a question? Because now we're going to do a bunch of problems in the book. All right, take a look at problem number 9 on page 298. So see the graph in number 9? Here we go. As x approaches, so use your finger. As x approaches -3 from the left, what is y doing?
It's rising.
As you approach -3 from the left, the graph is going up.
Oh no, it's falling.
It's falling, right?
Yep.
-infinity.
Yep.
All right, number 10. As you approach -3 from the right, what is y doing? Someone besides Mark. As you approach -3 from the right, what is the graph doing?
Is it reaching the asymptote?
Hold on, I'm gonna put it up here. So I'm copying the graph from the book. So you have a vertical asymptote at 1. You have a vertical asymptote at -3. The graph is doing this in the middle. On the right, it's doing this. And on the left, it's doing this. So in number 10, watch my hand. This is -3 for x, right? So as x approaches -3 from the left, this is number 9, as x approaches -3 from the left, what is y doing? So as I approach, what is y doing? Don't look on the right. Approaching from the left, don't look on the right. You can't see that. So as you approach -3 from the left, what is y doing?
Approaching the asymptote. Falling.
Right. As you walk to the right from the left, I mean to the -3 from the left, the graph is falling. Okay? As you approach -3 from the right, what is the graph doing as you approach from the right?
Rising.
It's rising to positive infinity. Good. Okay, you're seeing it. Okay, number 11. As you approach 1 from the left, so now we're walking this way. So as you approach 1 from the left, what is the graph doing? And don't look at the right. You're approaching from the left. So as you approach 1 from the left, what is the graph doing?
Falling.
Falling. Good. Negative infinity. All right, number 12. As you approach 1 from the right, what is the graph doing?
Rising.
It's rising, positive infinity. All right, now here we go. As you approach negative infinity, what is the graph doing? So as you walk to negative infinity, as you go this way, what is the graph doing? Is it going up forever? No, it's not.
Staying constant.
Exactly. It's actually not, okay, that's a good word. It's actually not staying constant, but it is approaching a constant. It is approaching 0. So think about this. It's forever approaching 0 and never hitting it. Think about that. So way over there at -1,000,000, it's still approaching 0. It's never going to hit it, ever. It always approaches 0. Isn't that crazy? All right, so how about this one? As you walk to the right forever, as x approaches infinity, what's the graph doing? The graph forever approaches what?
0.
0. The asymptote, right. Exactly. It's approaching the asymptote, I think Mark said, and then somebody said it's approaching 0. That's right. It's approaching 0. Okay, now, do you want to do some more of these, or are you guys okay? Because we can look at number 15 if you want. I'm not going to put it on the board, though. Are you guys okay, or is anybody still unsure?
Can we do one more?
Yeah. Okay, everybody look at number 15 in your book. I'm on page 399. See the graph? 3 different pieces. As x approaches 1 from the right, that's what that little plus means. So as x approaches 1 from the right, what's the graph doing?
It's rising.
It's going up forever to infinity, right? Number 16, as you approach 1 from the left, what is the graph doing?
Falling.
Say it again.
Is it rising?
As you approach 1 from the left, you're approaching 1 from the left.
It looks like it crosses the horizontal.
No. You're approaching one from the left. So when you approach one from the left, don't look up. The graph is below. So as you approach one from the left, what is the graph doing? Don't look on the right.
Falling.
It's falling. Okay, 17. As you approach -2 from the right, so now you're approaching -2 from the right, what is the graph doing?
It's falling.
It's falling. As you approach -2 from the left, what is the graph doing?
Rising.
Rising. And then finally, as you approach infinity, what is the graph doing?
Reaching the asymptote.
Yes, it's approaching the asymptote, so it's approaching 1. Okay? As you go to the left forever, what is the graph doing? It's approaching what?
The asymptote.
Which is 1, right?
Yeah.
Mark, are you okay?
Yeah.
All right, that's arrow notation. Use it a lot in calculus. All right, so we talked about the domain, we talked about vertical asymptotes, we talked about arrow notation, we talked about horizontal asymptotes, we looked at graphs on the calculator, and now we're ready to graph. Now, I put this in your assignment. I haven't posted it yet because I didn't know when I was going to finish the lesson, but I put these steps in your assignment so you could follow these steps. I also put this in the material section. So we're going to follow these steps to graph, and I'm going to try to do as many problems as I can. We'll see what happens here. All right, so here we go. So we did all that to graph. So here's your problem. It is a function. It does pass the vertical line test, and this is a rational function. Now, I do want you to know that the top represents P of X and the bottom represents Q of X. And the way you're going to remember that, it's in alphabetical order, element OPQ. So the first thing we're going to do, you can do it or not, but you're going to see the value of it is look for symmetry. So to find symmetry, you're going to set X equal to -X, and wherever you see an X, you're going to put a -X. And what I get is -2X over -X minus 1. Okay, now, if this turns out to be the same exact function, you have y-axis symmetry. If it turns out to be exactly opposite, like instead of positive, positive, negative, it turns out to be negative, negative, positive, which it's not, you would have, if you have opposite, you have origin symmetry. So let me show you what they look like. So y-axis symmetry would look like this. Origin symmetry would look like this. Over here, you have neither, because it's not exactly the same and it's not exactly opposite. So that didn't help at all. All right, so let's go to number 2. The next thing we're going to do is we're going to find the y-intercept. To find the y-intercept, you set x equal to 0 always. So this would be 2 times 0. This would be 0 minus 1. So you end up with 0 over -1, which is just 0. So your y-intercept is 0, 0. The third thing we're going to do is we're going to find the x-intercepts. And to find the x-intercepts, you set the top equal to 0. So you're going to take 2x and set it equal to 0 and solve it, which in this case is just 0. And remember that the x-intercept is just a point, and you can write it as a solution set. The fourth thing is finding the vertical asymptotes. And to find those, you set q of x equal to 0, which is the denominator. So you're going to take x minus 1 and set it equal to 0. So x equals 1, and these are lines. So even though you're doing the same type of math, this is a point. That vertical asymptote is a line. And now you know why I've been being so strict about notation. So we want to keep it straight. X-intercepts are points. Vertical asymptotes are a line. And then the fifth one is the horizontal asymptote, which there can only be one. And you have to look at the conditions. I'm going to move this down. So the horizontal asymptote, you have to look at the function. 2x over x minus 1 means that n is equal to m. In other words, the degrees are equal, which means that your horizontal asymptote is the leading coefficient, 2 over 1. So your horizontal asymptote is 2. Okay, now what we're going to do is we're going to take all this information and graph. So I'm going to erase this. Do you guys want to ask me about anything over here before I erase it? So we did all that work just so we could graph this thing. Okay, so first of all, we didn't find any symmetry. That's going to help us later, though. The y-intercept was 0, 0, a point. The x-intercept is also 0, 0. You have a vertical asymptote at x equals 1, so draw it with an arrow. You have a horizontal asymptote at y equals 2. And now, unfortunately, what we have to do now is make a table. So what we have to do now is we have to pick 2 points to the left of the vertical asymptote. We already have 0. We need to pick -1. And you need to pick 2 points to the right of the vertical asymptote. Now, you can pick any points you want, but I recommend you pick points close to the vertical asymptote. You have to pick at least 2. You could pick more than 2 if you need to figure out the graph more. All right, so what we do is we're going to input some x values into our function. Which was what? 2x over x minus 1. And we're going to get out an ordered pair. So if we put in -1, we get 2 times -1 over -1 minus 1, which is -2 over -2, which is a +1. So we can graph left one, up one. Now, this graph is going along the asymptote and it's going along that asymptote. Now I'm going to pick 2. So we have 2 times 2 over 2 minus 1, which is 4 over 1, which is 4. So we have right 2, up 4. I need one more point. Pick 3. So this would be 2 times 3 over 3 minus 1, which is 6 over 2, which is 3. So we go right 3, up 3, and there's the other part of our graph. So there's your graph. Now, what I want to do is I want to put this on the calculator to see if we did it right. So you're going to go to your equation editor and delete everything out. Clear, clear, clear. And in the equation editor, you're going to put in 2x divided by parentheses x minus 1. And you're going to, so it's going to look like that. And you're going to hit graph. And we're going to find out all the flaws of the calculator. Not all, but lots. All right, ready? You see the vertical asymptote, how it's not dotted and it doesn't have arrows? That's wrong. You see how this doesn't even show a horizontal asymptote? That's wrong. You see how the parts of the graphs don't have arrows? That's wrong. So that's why I'm having you do this by hand, because the calculator is jacked up and it's important that you know what you're doing. So once again, see the vertical asymptote is not dotted. Doesn't have arrows, that's wrong. Doesn't even show the horizontal asymptote, and there is one. So when you go to Valley College or RCC or UC Riverside or UCLA, of course I want you to use the calculator. In fact, if you go to table, go to second table, you can see the table of values and you can see some of the values I have here. So if you scroll down, you can see my left 1, up 1. You can see my right 2, up 4. And you see where the asymptote is, there's an error. That means there's an asymptote. So I've showed you the equation editor today, y equals, you know how to graph, and you go second graph, you can get the table of values. All right, anybody want to ask me a question before we do another problem?
You said we picked the numbers closest to the vertical asymptote, right?
Yes. So you can pick any numbers you want, but the further you get, the harder the problem's going to be. So if you notice, we already had 0, 0, so I just picked -1, and then to the right, I picked 2 and 3. But you can pick any numbers you want. It's just going to be harder if you do. Let's do another problem. And I'm going to want you to see the benefit of symmetry if you figure out symmetry. Okay, here's your rational function. This time it's 3x squared divided by x squared minus 4. So this looks a little more complicated. The first thing we're going to do is we're going to look for symmetry. because it will help us graph. It'll make the table less work. So you're going to put in a negative x. So this would be 3 times negative x quantity squared over negative x quantity squared minus 4. Look what happens. We get 3x squared over x squared minus 4. That is exactly the same, which means we have y-axis symmetry. And when I make a table, I'm not going to pick things to the left. I'm not going to pick any negatives when I make the table because I'm going to cheat and use symmetry. I'll show you in a minute. The second thing we want to do is find the y-intercept. And we do that by setting x equal to 0. So we get 3 times 0 quantity squared over 0 squared minus 4, which is 0 over negative 4, which is just 0, 0. 0 over any number except 0 is 0. The third thing we're going to do is we're going to find the x-intercepts or the solutions. And we do that by setting the numerator equal to 0. So we take 3x squared and we set it equal to 0 and we solve it. We do have a quadratic, so you'd have to use one of the quadratic solving methods. I'll use square root method. When you take the square root, you get plus or minus 0. So your x-intercept is 0, 0, or you can write it in a solution set. The fourth thing we're going to do is we're going to find the vertical asymptote or asymptotes. And we do that by setting q of x equal to 0, which is the denominator. So that would be x squared minus 4 equals 0. And there's 2 ways you can do this. So this is a quadratic. So you can either solve by factoring or square roots. I'm going to show both. So if you like factoring, you just say x plus 2 times x minus 2. So your vertical asymptotes would be x equals negative 2, x equals positive 2. And I'm writing like, because those are lines. Up here, these were points. These are lines. If you use square root method, you isolate the square, take the square root of both sides, and don't forget plus or minus. So half of you are going to want to factor, half of you are going to want to use square root method. I don't care what you do. The only thing I care about is your notation. Make sure that you write this as a solution set. You write those as lines. All right, so now we're on the horizontal asymptote. There can only be one. And what we're looking at is we're looking at the function. We're looking at the degree of the variable on the top and the degree of the variable on the bottom, and they are equal. So n equals m, which means the horizontal asymptote is 3 over 1, which is just 3. All right, I'm going to do the graph over here. And before I make a table, I'm going to fill in all the missing parts. So first of all, we had y-axis symmetry, which means I'm not going to do anything on the left except copy the things from the right. So the first thing is the Y-intercept, which is right in the middle. The X-intercept is also 0, 0, so that didn't help. We have a vertical asymptote at 2. And we have a vertical asymptote at -2. And we have a horizontal asymptote at y equals 3. You guys see that? So now I'm ready to make my table. Now, remember what I told you. You're going to have to pick 2 points to the left of this asymptote. You're going to have to pick 2 points to the right, 2 points to the left of that one, 2 points. But here's the deal. I'm not going to do anything on the left because I have symmetry. So I'm going to pick 1. I'm going to pick 1, 3, and 4. 2 is an asymptote, so don't pick that one. So I'm going to pick, let me write this down, 3x squared over x squared minus 4. All right, so I'm going to pick 1. So this would be 3 times 1 quantity squared over 1 squared minus 4, which is 3 over -3, which is -1. So watch how I use symmetry. I'm going to go right 1, down 1, and then I'm going to copy left 1, down 1 there because I have y-axis symmetry. Now I'm going to pick 3. So I have 3 times 3 squared over 3 squared minus 4, which is, this is 9 times 3 or 27, over 9 minus 4 is 5. So 5 times what is 27 with 2 remaining is 5 2/5. So I'm going to go right 3. I'm going to go right 3 up 5 2/5. And I'm going to copy that at -3. So at -3, I'm going to also go up 5 2/5. So see how it looks just like a mirror? And by the way, this graph in the middle looks like this. So now I'm going to pick 1 more, and that's going to be 4. And this is going to be 3 times 4 quantity squared over 4 squared minus 4 ends up being 16 times 3 is 48, divided by 16 minus 4 is 12, and 12 times 4 is 48. So it's right 4 up 4. So check this out. If you're looking down, check this out. Over here. This graph goes like this. And if you copy left 4 up 4 over here, this graph goes like this. And so see the symmetry? See how the graph is symmetric about the y-axis? And see how much time that saved me not picking the negatives? Because what I did is I copied the positive x's to the negative x's by just reflecting over the y-axis. This is one graph, by the way. This is a rational function. It passes the vertical line test, but it's not a polynomial because it has breaks. The domain is all real numbers except -2 and 2. Right?
Yes.
And the vertical asymptotes are the lines, is 2 and -2, that make the denominator 0. All right, any questions or anybody want to ask me about anything, or can I erase it? Questions? Let's do another problem. Another rational function. We're going to go through the steps. We're going to look at the symmetry. So you put in negative x and see what you get. So this would be negative x quantity to the fourth. Make sure you put in parentheses. Negative x quantity squared plus 1. And it ends up being a positive x to the fourth over x squared plus 1. And guess what? We have y-axis symmetry again, which is going to help. The second thing we do is we find the y-intercept. And that's by always setting x equal to 0. So we get 0 to the fourth over 0 squared plus 1, which is 0 over 1, which any 0 over any number is 0. We're going to find the x-intercepts by taking the numerator and setting it equal to 0. So we have x to the fourth equal to 0. And what you're going to do here is if you take the fourth root, just like we take square root, if you take the fourth root of both sides and x comes out and that's plus or minus 0. So this x-intercept is 0. The y-intercepts, you take the denominator and set it equal to 0 and do the same type of math. So this would be x squared plus 1. Well, check this out. If you solve for x, subtract 1 from both sides, and you take the square root of both sides, you get plus or minus an imaginary. And that means no, it's not y-intercept, sorry. Vertical asymptotes, right? Vertical asymptotes. That means there's no vertical asymptote. And then finally, the horizontal asymptotes. We look at the powers. So you have n greater than m. And that means that there's no horizontal asymptote. So we're not having very good luck right now. So we're not finding out a lot of information. And that every time we don't have a lot of information, it means our table is going to be bigger. But we do have y-axis symmetry. All right, so let me start the graph. So we do have y-axis symmetry, that's good. Our y-intercept is 0, 0. We don't have a vertical asymptote because we got an imaginary, and we have no horizontal. This is all we have to go by. So that means we're going to have to do a lot of work in the table to figure out what's going on, but we do have y-axis symmetry, so I'm not going to pick any negatives. Okay, so this time the function is what? It's x to the 4th over x squared plus 1. And I'm only going to pick numbers to the right. So I'm going to pick 1, 2, 3. See if I can tell what's going on. So 1 would be 1 to the 4th over 1 squared plus 1. 1 over 2 would be a half. So you go right 1 up a half, and I'm going to copy that over here because I have y-axis symmetry. And then I'm going to put in a 2, which would be 2 to the 4th over 2 squared plus 1, which is 16 over 5, which is 5 and 1/5. Something's not right. Should be 3 and 1/5, right? 3 and 1/5. So you go right 3 up 3 and 1/5, and I can do the same thing over here. I can go left 3 up 3 and 1/5 and copy for symmetry, and that's good enough. So my graph looks like this. No, wait a minute, that should be right 2. Sorry, this should be right 2 up 3 and 1/5. And this should be left 2 up 3 and 1/5. And if you want to do another point, you can, but we're going to put this on a calculator. This is not a quadratic, by the way, but it kind of flattens out. So I want you to see it on the calculator. So go into y equals. And how you do this, you put x caret 4. So the caret key is a black key. I mean, over here, it's a caret key. It looks like this. So you put x caret 4 divided by parenthesis x squared plus 1 parenthesis. So it looks like this. And then you hit graph, and it looks like a parabola. It's kind of been flattened out at the bottom. See how it's flattened out? It's not a parabola. And if you want to look at the table, you could go to second table, and you can see the table of values, and you can see that if you pick 1, you get 0.5, which is 1/2. If you pick 2, you get 3.2. Those are in decimal, so those would be a little more difficult to graph. So the symmetry really helps because we don't have to put any negatives in the table if we have y-axis symmetry. Now, I have done everything in this lesson except for slant asymptotes. And I'm not going to do it right now. So I might do it in the future. I may not, but I'm definitely not doing it right now. Because if I haven't already blown your mind, I'm definitely going to blow your mind with slant asymptotes. So I'm not going to do that right now. So we have no school on Monday. So that means today, you have today, Friday, Saturday, Sunday, Monday to work on this assignment. If you blow it off for 5 days, that's the problem. You have to do the math every day. Now, Sunday is Super Bowl, so I can understand you not doing math, then that's fine. But you better be doing math Thursday, Friday, Saturday, Sunday, Super Bowl, Monday's a holiday, and you're back with me on Tuesday. If you come back on Tuesday and you're totally confused, that's why you're failing tests. So when we're in school, you see me every day. But that's not how this distance learning goes, and you are not being self-disciplined. That's the problem. You must do the math every day. So if you do the math every day, you're going to see a big change. If you skip 5 days, you're going to continue in the way you're going, some of you. So I have not posted this yet because I didn't know when I was going to finish the lesson. But that doesn't mean you don't work. You know what the lesson is. It's 2.6. You know I'm going to assign the odds. Do them. So you should be able to do all these problems now except for the slant asymptote. You should be able to find the domain. You should be able to do the arrow notation. You should be able to find the vertical asymptotes. You should be able to find the horizontal asymptotes. And you should be able to graph. If you don't know how to do that, you can look at your notes. If that doesn't help, and I'm just a horrible, awful teacher, you can watch the video over and over again to see if any of that makes sense. You could be working with your classmates, but I'm telling you right now, if you have me do 95% of the work and you're doing nothing or 5%, that's not going to work. Because right now, period 1, they flood me with questions. You guys don't ask any questions. So sometimes Jerry will comment, Mark asks questions, Victor, but sometimes Andres, but you guys have got to ask me questions. That's the only way we're going to get through this. If you do not let your pride down and you do not ask questions, you're going to fail the class. I'm just letting you know. So you better get with it. You better understand what I'm saying, because I'm not going to let you just slide by like other people have your whole life. So that's just not going to happen in this class. And the reason why is I'm not going to set you up for failure for the next class. So you're not going to go to the next math teacher and they're going to say, oh, they got a B or a C or an A. No, you're going to have a legitimate grade. Because I want that next teacher to know where you're at. So I'm going to help you all you want, but you got to take advantage of it. And a lot of you just aren't doing that. All right, anybody want to ask me any questions about anything? Domain, the arrow notation, anything?
So for the problem we just did, there was no horizontal or vertical asymptote. So you just picked 1, 2, and 3. And does that, and say like there's another problem like that, do you still pick 1, 2, and 3?
Okay, the reason why I picked 1, 2, and 3 is because I had y-axis symmetry. So because I have y-axis symmetry, I'm just picking positive numbers. There is no vertical asymptote because remember, if you have a vertical asymptote, you want to pick 2 points to the left and 2 points to the right of a vertical asymptote. If there's more than one vertical asymptote, you have to pick 2 to the left, 2 to the right, and 2 to the left, 2 to the right of the other one. But the reason why I picked these numbers on this mark was because I had y-axis symmetry. If I didn't have y-axis symmetry, I would have had to pick probably 1, 2, and 3. I would have had to pick -1, negative. I would have had to pick like 7 numbers because you're trying to get an idea about what the graph looks like, right? So if we don't know what the graph looks like, you're going to have to pick more numbers for this table. I don't know about you, but this is a pain right here. This is a lot of work over here. So you want to use all those things I told you to try to help you graph so that you don't have to do a lot of this. This is horrible. Okay, now I'm going to start you on another problem in your book. It's 77. So let's take a look at 77. All right, check this out. I'm not going to do the whole thing. I'm just going to talk about it. Number 77 is a function, not a polynomial though. It's got this thing on the top, x squared plus x minus 12 divided by x squared minus 4. So if you do the symmetry thing, there's not going to be any symmetry. So I just want to do a couple things here. First of all, if you want to find the x-intercepts, remember you're setting the top equal to 0. So this would be x squared plus x minus 12. And wouldn't you have to factor that? Isn't that a quadratic? So you either factor it or use the quadratic formula. I don't know about you. I don't want to use the quadratic formula. So if you factor this, what multiplies to give -12 and adds to give 1?
3 and 4.
Yeah. So that would be +3 and a -4. So your x-intercepts are -4 and 3. And so when you do your graph, that helps a lot. You're going to put a point at -4 and 3. And if you found the vertical asymptotes, you would take the denominator, which is also a quadratic, and like I said, you can use factoring or square root method. I'm just going to use factoring again. This is the difference of squares. But I'm not going to write it like that this time. These are lines. So this would be x is equal to -2 and x is equal to +2. And those are lines. So you have a vertical asymptote at -2 and you have a vertical asymptote at +2. And so see this mark? On this one, you could pick -3 because you already have a point. In here, you're going to have to pick 2 points. Maybe you know the y, we could find the y-intercept. And on the right, you would pick 1 more point, like 4. So let me see about the y-intercept. If you set x equal to 0, this is the y-intercept, you get 0 squared plus 0 minus 12 over 0 squared minus 4. Well, isn't that -12 divided by -4? Yes or no?
Yes.
Yeah.
So wouldn't that be a +3? So wouldn't the y-intercept be 0 up 3? And I don't know about you, but this graph looks crazy right now. There's definitely no symmetry. So let's do it. Let's since we have time, let's do the table and see what we get, and then we'll put it on the calculator to see how close we got. So that looks like, I don't know about you, that looks like nothing to me. So what was it? What was the function? X squared plus x minus 12 over x squared, is it x squared minus 4? So I'm going to work in the middle first. So I'm going to pick 1. So this would be 1 squared plus 1 minus 12 over 1 squared minus 4. So that would be 1 plus 1 is 2, minus 12 is negative 10, over 1 minus 4 is negative 3. That's positive 3 1/3. So this thing is going off toward that asymptote. I can already tell it's going like this. Then I'm going to pick negative 1 because I don't know what's going on. So this would be negative 1 quantity squared minus 1 minus 12 over negative 1 quantity squared minus 4. Got to be careful. This would be a positive 1 minus 1 minus 12 over positive 1 minus 4. So that would be 1 minus 13 is negative 12 over negative 3 would be what, a positive 4? So left 1 up 4. Wow. Weird. Okay, I'm going to erase this. Is that okay if I erase this? Yeah. So the next number I'm going to put in is negative 3. So negative 3 would be negative 3 quantity squared minus 3 minus 12 over negative 3 quantity squared minus 4. And that's going to be 9 minus 15 over 9 minus 4 is 5, which is going to be what, negative 6/5, which is negative 1 1/5. So negative 3 and negative 1 1/5. So this is definitely going along this asymptote. And I guess this one's just going off like that. We'll see. And then we already have 3, so I'm going to pick 4. So this would be 4 squared plus 4 minus 12 is 4 squared minus 4. So this would be 16 plus 4 is 20 minus 12 over 16 minus 4 is 12. I think that's right. 16 minus 4 is 12. So that would be what, 8/12? This is hard. So that would be 2/3. So write 4 up 2/3. Oh, you know what? We have a horizontal asymptote. We didn't do that. So let's do the horizontal asymptote. N equals M. And that means that our horizontal asymptote is 1 over 1 or 1. Now that makes sense. So if our horizontal asymptote is 1, you know what that means? The graph runs along the horizontal asymptote. And there's your graph. So let's put it on the calculator and see if we got it. So I'm going to go into the equation editor and clean this out. And I'm going to put x squared, parentheses, x squared plus x minus 12 parentheses divided by x squared, parentheses, x squared minus 4, parentheses. So that's what it looks like. Hit graph. See that? So notice there's no horizontal asymptote. Notice there's no arrows. Notice that the vertical asymptotes aren't dotted. So see how the calculator could be really confusing to people that don't know what they're doing? So to be honest with you, this is going to be the biggest challenge, your basic math. So your basic math skills are going to be your biggest challenge. All right. Well, next week we're on that special schedule because we have a Monday holiday. I will not see you till Tuesday. So I hope you don't blow your math off until Tuesday, or we're not continuing in a good way. So you're welcome to stay. We have 3 minutes. You're welcome to stay with me and ask questions. Otherwise, I won't see you until Tuesday. All right. All right. I'll see you guys later.